and I was one of you guys, I would be sitting in a seat like you or watching online. I was very lucky to meet Miguel in the early days of Xamarin, and I emailed him one day, said, can I come work for you? And it worked out for me. um, so I've been working on Xamarin Android specifically around the build and seeing what we can do to improve in that area. And getting into it, there's obviously a lot to learn. We'll kind of get into this here. So whoever made this picture, I want to say thank you. This looks really awesome. Fortunately, it has my creepy face on it, but we'll try to live up to what that picture means, and I don't know if we'll get there. So why are we here? There are a lot of checkboxes. If you've looked in the options menu of a Xamarin Android project, there are things like, there's scary words. There's like linker, AOT, LLVM, DEX compiler. Some of these are new. And I mean, who really knows what all those mean except for maybe me, right? So we're going to go through, we're going to try to explain what a lot of these things are. The other thing that we want to get across is like which of these settings are for debug builds while you're working on your app, and which settings are for release builds like when you're going to ship to your customers. Because a lot of these settings basically, they take longer to run, right? Obviously, your release builds are going to be optimized, and you don't want to do that kind of thing for your debug builds. And then I'm going to show you both some tips and tricks of stuff you may not know about that are pretty easy. You can just turn it on in your app, and it's not something that's well documented or whatever. And I'm going to show some new features that are coming, and some you can use today. So let's get into it. And if you focus more on iOS or maybe just other .NET things, I think this talk will still be useful. Because I'm going to just be explaining like some general .NET things. So if you open Visual Studio right now and you go to the project options, this is the screen you get. You probably can't even read it well, but I don't know about you, but I'm already getting confused and getting lost here. Well, we'll see what we can do maybe to improve this. But what's even worse is there's an advanced button, and you click that and you get even more things in your face that you don't know what it means, right? So what I'm going to try to get across here is like which settings are actually important, and which ones maybe you don't need to worry about. And more importantly, we should actually maybe understand what they do, right? So let's say you get an update for Visual Studio, and there's a new checkbox. Now, are you going to check that box? I would probably check that box. But who knows what it does, right? We could put any text there, and you really need to research, like actually understand what the checkbox means. What if this started a Twitch stream when you built your app, right? Who knows? So now let's get into like actually explaining some things. If you've been a .NET developer for a while, you've probably heard JIT. You've heard this term. You've heard AOT if you're a Xamarin developer, you've heard this term. And they're very, confusing. Even like Joe Biden, he literally can't even. And I don't know if I can literally even right now either. So to explain this, let's look at Joe for a minute. I started out with C# right out of college. It was probably like in 2006. And I would hear about this word JIT, and it just kind of went over my head. So I'm going to kind of explain what that actually is, and in a way that I hope that my past self would have understood. So this is a C program, Hello World, and this looks understandable, looks reasonable, even if you don't know C. It's basically gonna print hello world. And if you use your favorite C compiler, you end up with assembly code that looks like this. This is actually Mac assembly code for a 32-bit Mac, right? I chose this one because it was the least scary looking, but is still pretty scary. So that's what happens. If you compile C, you get that. And your CPU on your computer can interpret that code and run it. So one of the benefits here, when you compile C, the same code will work on different processors. And unfortunately, you have to recompile the app for every processor and every operating system, right? So it's not, your code is portable, but you have to recompile it. Now let's contrast that with C#. Probably more familiar with what's going on here. This is pretty simple. This is just the exact same program, hello world. Now you compile that with Visual Studio, or maybe you do it command line, whatever, and you get IL, right? That's MSIL's Microsoft Intermediate Language. And you get the same thing. You could also write an equivalent hello world in F# or VB.NET, and it gets compiled down to this. So if you think about that for a minute, how does this IL code actually run on the computer that you're using, right? It's got to get down to that scary assembly code we looked at before. Well, luckily we have the .NET runtime, and if you hear people use this word runtime, that is what makes this happen. So it loads the IL, right, as your program starts, and each method is compiled just in time. And that's actually what JIT means. That's what it stands for. Just in time, each method is compiled from IL to assembler on demand, right? And what's the benefit you get there is you don't have to recompile your app for every platform. You just have a DLL file or an exe, and it will run on Mono, on Mac, on .NET Core, you name it. You know all the platforms we have. But then there's another thing, right? There's ahead of time, or AOT. And what this means is we're JITting everything ahead of time, right? You're going to pay a build time cost, but you get a specific compiled code for that platform. And the thing that's important here is that specifically iOS devices, they can't JIT. If you think about what the JIT does, is it compiles this code into memory and then runs it. Well, iOS at the operating system level can't do that. Like Apple has restricted that ability. So kind of explain this a little, to break it down further. JIT apps will have smaller file size, support multiple CPUs, and they'll be a little slower on startup. And AOT is going to be a lot larger, and you're going to have to rebuild it per CPU, but at the expense of a faster startup. So it's really a trade-off. iOS, you have no choice, it's AOT, but Android, we have both. So let's talk about another scary thing. You've probably heard about the linker. And this is a feature of Mono, and so we use it in Xamarin products. What this thing does is it strips down and optimizes .NET code. If you think about an iOS app or an Android app, each app is self-contained. Like, you can't install this runtime that is phone-wide and like runs things, right? That's not something that we can ship on Google Play or the iOS App Store. So you have a copy of Mono in your app, right? Should have had these reordered, but so you think about that. The entire BCL is in your app. You want to remove the code you're not using. So we have a setting called SDK Assemblies Only, which is a drop-down box that will strip, and this is the safest option, right? It strips out any of the BCL, Xamarin Android, or Xamarin iOS libraries. You think about all the APIs available to you from iOS or Android. If you're not using those, then we should strip those out of your app. And this is the safest option that is in the default right now. If you've used full, this strips your code as well as any of the framework code. And so let's say, for example, you're using Xamarin Forms or JSON.NET or something like that, you may not be using every feature, every type in that library, and so it's going to strip it out. And the only problem is going to be is if you have some use of system reflection or something that the linker doesn't understand, you might have to add a workaround to get around that. So that was kind of .NET world. Let's kind of go into the Android world. Let's talk about DEX. And you may have heard what that is. Within an APK file, there is a classes.dex file. And Android is very weird, right? It runs Java, but it's a different Java. It's Android's Java. And so it has its own format for compiled Java code. And so the Xamarin Android build, it generates Java source code. And we have to compile it. And then we get Java bytecode. Well, we have to run a tool that turns that into something Android even understands. So at build time, there's this whole pipeline of things that, as a C# developer is just kind of hidden from you. You hit build and you see that progress bar. and to me, I think about all this and I think, LOL, why did Google do this? But that's where we live, right? One last confusing thing is an ABI. You may have heard this word. It's on the advanced screen, right? And that it stands for some Android, something binary interface, whatever. But it's basically a CPU type, right? And you've seen these words if you've looked in our options menu, like Army ABI, V7A. That's just a 32-bit ARM device, like a phone, right? And there's also a 64-bit version of the same thing, which has another weird, confusing name, right? The thing that you've been able to do for a while is 64-bit devices can run the 32-bit code, right? And Google Play recently has been requiring that you support both. And so this is kind of a new thing that you might actually need to check that box if you don't have it yet. There's a couple other options for Android apps. x86 is not, you don't see this much on Google Play, but some things that would fit in this category would be like a Chromebook, which can run Android apps now. Also, your Android emulator would be x86, and there's a 64-bit. And so the thing you need to take away from this, release apps, if you're submitting to Google Play, you should be able to just get away with checking the first two and not worry about the others unless you have a specific use case, like some user says, I have this x86 device, I want your app to work. And for debug mode, you don't really have to worry about this, just leave whatever's default in there, and we'll figure that out for you. And I don't know about you, this is how I feel right now, and I'm the one up here dishing this out, right? So let's take a moment and kind of let's put our head back together. Let's get practical. What should you actually put in your app? Like, if you go to the options screen, like, what should you look at right now today and make sure you have set right? And I think the most important thing is to understand what settings are for debug and which ones for release. So debug, obvious you have to turn these on, right? You may have seen this checkbox, use shared runtime or use fast deployment. That's what makes the build fast. If you uncheck that box, it's going to do all kinds of stuff. In debug mode, we have a feature where we don't produce an APK every time. We sideload the .NET assemblies onto the device. So if you change one line of code, we don't want to repackage your whole APK and install it. We want to just send the one assembly over. And that is what this setting does. So don't uncheck it. If you have a problem with this, we should really look into figuring it out. And I think we're in a better place today than we were with this setting maybe a couple of years ago. Back in the day, this used to be a thing developers would uncheck, and we tried to get people from doing that. Debug mode, you just want to check this if you want to be able to have breakpoints. So if your breakpoints stop working, you might check that. That's all I need to say about that. These are the settings you do not want to enable in debug mode, right? These are the settings that is for release builds, and it will slow your build down to turn these on in debug mode. So you don't need to use AOT, no linker, and the code shrinker is a new setting, but that is ProGuard basically, and we'll talk about that. So let's talk about an optimal release build of your app, like what settings you should set. The code shrinker, this used to be a checkbox that just said enable ProGuard. Well, we have a new code shrinker, and so this is now a drop-down you can pick between them. And what this does is this is the same as the linker, but for your DEX files, right? So your Java code, so you probably are using the support libraries in your app. Right now, if you don't have this on, all that Java code is just in your app unused, right? So that's what that does, right? And if you're in a release build, you might want to consider doing the full linker option here, which is SDK and user assemblies. And there may be some tweaks you have to do to get that to work in your app. Probably not. Like most apps, I've turned that on. It just works. What you'll see is on startup, you might get a crash that says like missing method exception, and it should tell you what type was missing. And so you should be able to add an exclusion for that. So another option is AOT, right? This is optional. This is going to get you faster startup at the cost of a bigger APK. So that's another thing you can consider for release mode. A few other settings to talk about. These are just maybe so that you know what they are. A lot of these are going to be optional. If you've heard about DEX, the DEX limit, Android DEX files have a limit of like 64,000 methods. And that is just a limitation of the file format, right? And so to work around this, they have an option that creates multiple DEX files within your APK. And they call that multi-DEX. Unfortunately, there's a lot of work to figure out, like certain types have to be in the first DEX file. So anything that's used on startup of your app has to be in the first DEX file. And so there's a build time cost for the Android tooling to figure that out. So the thing to take away is, you can use this checkbox if you absolutely have to, right? Your app won't build unless you check it, and that's what's happening here. For debug builds, you absolutely should use multi-DEX, but in release builds, you might consider a code shrinker instead because it will strip out your Java code so that you don't need multi-DEX, right? And that's a better situation for release builds. The other thing I'll say is in recent releases, we've actually made some improvements where in 16.2, Android apps by default, Xamarin Android apps, should be under the DEX limit, more likely. We found an issue that I was able to rework things to be more like what Android Studio does in Java. So going forward, I'm hoping that less people will even have to worry about this box, and we'll find out about that. LLVM, there's another checkbox next to AOT. Only try this out if you're already using AOT, right? And I'm speaking about Xamarin Android here. Don't try to check them both at the same time. Try one, see if it's working for you, use it in your app, and then try adding LLVM later. What this does is it just makes the code smaller, makes it start up faster. Yeah?
So does using the code shrinker help those of us who are using Google Play Store stuff, which is usually the reason that my apps in the past have gone over?
Yeah, so he's asking about multi-DEX if using like Google Play libraries, Google Play services, would get you over the multi-DEX limit. Yes, absolutely it would.
But using the code shrinker fix that?
Yeah, so using the code shrinker will strip any Java code, right? So you think about any native library that you have in your app, it's gonna strip it out. One thing to mention is just like the linker, it might strip out too much. And so they have rules to prevent stripping certain types if that happens. So there is a little work to enable ProGuard. So let's go into I'll probably get into some of these things more later too. Let's talk about some tips, tricks, and just general things that you can do in your app to make things better and get a little magic. So this is a setting. This is just a .NET setting. It's been around a while, but people don't seem to know about it. If you look in your CS proj file, there's a setting that says debug type. And you want to set that. Basically, all you need to know is just set it to portable for Xamarin projects. That's all you need to know. Debug and release. Otherwise, we have to convert that to a format that Mono supports. And this is something that you don't even care about. You just want your debugging to work, right? So if you change it to portable, we're going to skip that build time costs. And this is especially important for anyone who has NuGet packages. Does anyone have their own NuGet package out there? If you don't have this setting enabled, basically anyone who consumes your package is going to pay this build time cost. And to know what the wrong ones are, right? They will say full or PDB only, and these are Windows-specific formats, and that is why the new one is portable. So this is easy. Just change it to this, and you'll get a little build time boost. Another one is produce reference assembly. This one's maybe a little more complicated. This is a feature of Roslyn and MS Build. If you know how MS Build works, let's say you have a net standard project and an Android head project, right? So you have all your forms code in the net standard project, and you change some forms code, right? Well, MS Build by default is going to build both projects. That's just kind of how MS Build has always worked, is that if any dependency changes, you got to build the whole thing all the way up, right? Well, they added a setting to get around this, produce reference assembly. And what this does is, on the first build, you'll get this reference assembly, which is all the public APIs of your net standard project. It's just sitting there in your bin directory. It'll be like, so your assembly is foo.dll. There'll be a ref folder, and in there you'll see a foo.dll that does not have any code in it. It just has the shape of what your types are in that assembly. And so if you make a small code change, let's say you change your XAML, you add a console write line, or you just change a label's text or something like that, that doesn't change the public API of that assembly. And we don't need to rebuild the head project, right? And so this is going to be a huge performance improvement for incremental builds. If you're changing small changes, enabling this setting is going to help you. Yes, this is in the CS project file. The only drawback, we did put this in the template. The drawback is that we've seen some issues with iOS projects where you don't see the changes. So I'm working through that, and we should be able to get this something that everyone can use across the board soon. But you can go ahead and use this today with Android. It works. And it's probably going to work better on Windows right now, because the change is actually in Roslyn, and there's a newer Roslyn on Windows. So if you've heard about apt, Android tooling is complicated. I don't know. There's a lot of acronyms. Apt is Android Asset Packaging Tool. And this thing does like everything related to Android. It takes all your Android resources, your assets, and it packages them into this binary format, uses your Android manifest, and creates the base of the APK. And this is just the core of Android tooling that like Xamarin sits on top of. Like we can't get away from using apt. We have to run it. And because it does so much, it's kind of slow. So Google has recently created apt 2, and this is just kind of the next generation rewrite. Google likes to sunset things and kind of start from scratch, and that's what's happening here. And one thing they've done is they've created 2 steps, right? There's a compile step and a link step. And that's so that they can make incremental builds better. So compile will go compile everything you have in your app, and at the end, link will put it together in the APK. So if you change an Android XML layout file, or add a new image, we don't need to rebuild the world anymore with app 2. It can just build the resources in your app and then link everything together at the end. And if you think about like the Android support libraries, they have resources in there that if you're using the old app, it's going to build those every time. So this setting is obviously going to be more useful for classic Xamarin Android apps, not a Xamarin Forms app, but it still helps for Xamarin Forms apps. Like while you're adding images, maybe you change a style that's global. But if you're editing Android XML layouts, you absolutely should try out this setting. So let's talk about some more new stuff, right? We talked about DEX and what that is. In the past, we used a tool, this is from Android again, called DX, that it would take compiled Java code and convert it to DEX. Well, Google creates more stuff that has weird names called D8 and R8. And I think they're kind of going after the name V8, if you've heard of the JavaScript engine called V8 that's in Chrome. I think that's why they named it that. I don't know, really, but D8 is faster and in general can produce smaller code. It also supports newer Java language features in a much better way than before. And R8 is kind of like the companion to D8. It does what ProGuard does. It is a code shrinker for Java code, and it also can support multi-dex. And so in the old world where you use DX and ProGuard, it's running two tools. It's starting up the Java JVM twice for that. It's running two commands. And R8 is faster because it can just do everything in one pass, right? It can do all the work at once and doesn't have to start up twice. And that's the reason that these things are better. That's part of the reason. So let's look at an app. You've heard about the Smart Hotel app. We tend to talk about it a lot. So I just did some quick comparisons on my machine. I have a new PC that is, unfortunately, it's pretty beastly. So the numbers I'm going to show, you might be like, well, that was fast for your machine, but this is what happened for me. So I just checked out their repo and I just built it, right? This was a fresh build. And the first build was like over 50 seconds or so. And I've seen this app take 1.5 minutes or 2 minutes, depending on the machine. But this was a fast machine. And I just changed a few settings. They had multi-dex on, which they used to need it. But for the newer version of Xamarin Android, they did not need it anymore because we had fixed some issues there. I changed debug type to portable. I turned on D8. And I saved 5 seconds off the build just by changing these settings. And let's say your machine's not as fast as mine. I could see you might see double that improvement just by changing those settings. And then an incremental build, different settings help this, obviously. But I enabled produce reference assembly that we talked about just now in the debug type portable. And it changed just a second off my development loop to actually build that. Yeah, my machine, I was seeing about 5 seconds on this. This was just the build, not the deploy. But yeah, I could see that taking, on a slower machine, like 10 seconds. So here's the APK size. Before I did anything, the app was like 45 megabytes, right? Well, I enabled D8R8, turned off multi-dex, and I saved immediately 6 megabytes off my APK size. And that's just by checking some boxes. And this app was lucky that I didn't really have to change anything. It just worked. And I think part of that is it's using the latest Xamarin Forms. And they have some default settings for ProGuard and R8 that should get things working for you. But however, when you enable AOT, you can see what happened to the app, right? It went over 60 megs, right? So that's a trade-off you need to decide for yourself. Is app startup really important to me, or is APK size important to me? And that's where we got the new profiled AOT option that James talked about earlier today, that is kind of the best of both worlds. So when I enabled that with my other improvements, the APK came out the same size as before, but startup so much quicker, and it's a win-win. So that may be the way to go. Profiled AOT is in the 16.2 preview right now, or 8 to preview on Mac. So you might give that a shot. So let's talk about one other thing, Android app bundles, which is another thing very exciting. I don't know this guy, Joel Anderson. He looks trustworthy, maybe. Well, at least it's a screenshot of Google Play, and he has every API checked, right? Before, his app was 17 megs, and now with Android app bundle support, it's from 8.6 megs to 9.2 megs. So we have this right now in the 16.2 preview. That's how this guy tried it, is he went to our preview channel and tried this out. We don't yet have UIs for this, so it's not that easy to use right now. But if you really want to get your hands on it, you can do it right now. I should probably document better somewhere how to do it. I think right now you would have to go to the GitHub pull request and like look at a comment to figure it out. I just said that. And what does this actually do, right? James had that nice diagram, right? It actually, an app bundle is multiple APKs. It's an APK that's the base, and then there's an APK for each language, each DPI, each processor type. So that's pretty complicated, but luckily you as the developer, you don't have to change anything. You should just get a drop-down that says, I want to make an APK or I want to make an app bundle. And that's what we want to work for you. Yeah. So that's a new feature. I think we have some time. I didn't start a timer. So if anyone's got some questions, I think there's a mic right here. Or you can just stand up.
I'll shout.
Yes.
If you're doing private app distribution, so I'm guessing the app bundles is a Play Store thing, but if you don't want to do a separate build for every single architecture, is it still worth it to do the app bundle and then just pluck out the different APKs, or is that not?
That's tough. So they have another tool called, well, the question was if you could distribute app bundles yourself. Like, let's say you had an internal server with APKs on it. Without some server-side work, I don't know that that's going to be very easy, because there's a tool called Bundle Tool that does all this. And they're actually running that on Google Play's servers to probably on demand generate appropriate APK for each device. But Bundle Tool is open source. It's on GitHub. Like, it is possible, but honestly, you might be better off using, there's an option called APK per ABI have right now. Not a lot of people know about it. You might try that instead. And unfortunately, that would mean that the user would have to pick which APK they want. Go ahead.
Can you talk about the R.Java stuff y'all just fixed?
Okay, yeah. So that's the thing I was talking about, multi-dex, how we made it better. I actually wrote a blog post about that. I was looking at how many times we run apps during the Xamarin Android build, and it was a lot, right? And I was looking at what our code did, and we were running apps to generate R.Java. And what that is the resource IDs in Android. There's like, in C# you can type resource.id or whatever you named it, right? Well, there's that on the Java side too, so we need both. And we were running apps to generate that file. Well, I went and looked at Android Studio, the Android Gradle plugin, and they don't do that. They don't run apt. They just had some simple code that parses files and generates a Java file. So I ported that code to C#, and we do the same thing now. And that, not only did it make the build faster, but default apps that were hitting the multi-dex limit before, they were not hitting it anymore, right? Because we actually were doing a call in a way that it had every ID in the whole app put in there multiple times, and most of these weren't used. So that's a good blog post if you want to go to blogxamarin.com and like look for my name. That might be something interesting to look for. Anything else? Well, don't be afraid to come up to me later. My beard isn't that scary. So if any other questions later, feel free to come talk to me. I think that's all I got.